Hey, this is a more studio-focused update on TerrainParkour. Gonna talk about my workflow, fix a couple things, and let you see how that works, and just have fun. So I just noticed there's been some of these, what I call death pits. So these are holes through the world, or part of the world, which I'm fixing. They're not very easy to find, and the current terrain tools make it somewhat likely that if you're not careful, you will get them. I think they are programmatically findable to some degree, and it might be useful to have them not happen by default. But they're not such a bad thing. They tend to get discovered and fixed, naturally. Okay, so this is what the game looks like. There's terrain tools. Here's all the signs. I wanted to just show the overall structure of the game for people that are trying to learn and develop. So the main code location is in replicated storage and server script service. And then there's a bunch of stuff in starter player. So starter player is these are all the things that run in client context, like on the user side. So that's things like the leaderboard, actually doing a run, marathons, all the UIs, all the movement stuff. So we've got like movement, things like that. I don't want to go into that too much. Then we've got server script service. So these are things that run in the central world on the server. They have access to everything. They can submit scores, they can submit times. So it's pretty important that they not be exposed too easily to the users. Finally, we have replicated storage, and this is where scripts run that are copied around for use by other people. So sometimes local scripts will copy these, sometimes server scripts will copy them. It's very indistinct, but important to realize that the source of the person using it is distinct. So if a module script requires something from there, they will get it. If another module script requires it from there, if another server script storage module script requires it, they'll get the same one. So in server context, if script A requires one of these guys and script B does too, they get the same thing. And you can use global variables in the module as a way to communicate between module scripts. But if a local script on a client requires something like a generic, text utility or something, it won't be the same one. It will replicate over and it'll show up on the client and you won't have any shared variable. And it's a little bit hard to debug this type of thing. Okay, I wanted to quickly go over just as an example of how the dynamic stuff works. So there's two scripts. There's dynamic running, which is a local, it's a, this doesn't follow. Okay, dynamic running is a replicated storage script, which is required by a local script. So when a player joins, we load this up. It loads like my typing stuff. Go to definition doesn't work in Studio right now. It loads my typing stuff. So that you have like Lua types. It loads the getters for the functions that are used to communicate between client and server. Okay, let me just describe how it works. So it exposes two main methods, start dynamic and end dynamic. When you touch a sign, we do start dynamic. And when you end a race, we do end dynamic. What does this do? So when you do start dynamic, first it kills any existing dynamic run. Then it spawns a function which is just going to stay in space. It's going to get the lock. It's going to print if it waited. Hopefully it won't wait. It's going to find the nearest sign. And then it's going to tell the server, hey, this client wants to start. So it's going to invoke server, a dynamic running function with this data saying the command action name is start. There's some context like the player and that. and then it goes over to the server. When the server thinks, so how does this work? Wow, there's some weird bugs here. Okay, the server also loads the events for communication, loads some util stuff. We'll look at those things later. So then the server thing says, okay, it gets this function, and it says on server invoke. So when the client calls me, I'm going to call dynamic control server. What does dynamic control server do? Well, it's got two main modes. If the action was start, I use the same type here. If the action were start, it's going to start. If it's end, it's going to kill this thing. So how does this work? So when a client says I want to start, we create a loop monitor, which just stores like a Boolean, and we say we store it in a global place. Then we spawn a function that does while true. So this function just spins, and every 2.5 seconds, it's going to look up the location of the player. It gets the nearest signs to the player. It filters out the ones that have already been sent to the player. So in other words, the only ones that's going to get to hear and to do sign IDs are going to be the ones that the player needs to know about. They're like the 50, I guess it's, according to this, it's the 30 nearest signs, which we haven't already told the player the current status of as far as like people running them. So initially it'll be the nearest 30. If you don't move at all, it'll be the same 30 and they'll get filtered out, nothing will happen. If you move a little bit, maybe the sphere around you will cover something else. Okay, so then we get these things called frames. So a frame is a set of information you need to draw a UI that will give you context for your run to a certain sign. I don't think this ever actually happens, but it's here. Okay, so we get the frames, then we get the player, then we fire the client. Hey, we got these frames for you. So this is it. So client talks to server, server gets the data, server sends the data back to the client. Why don't I do it all on the client? Well, thinking about it, I think there's some technical restrictions. Like, I don't believe the client can do HTTP requests freely like that. Yeah, I'm sure it can't. So that's just an absolute restriction. And server knows a lot more stuff too, like has user found sign and things like that. Well, let's look at get nearest signs. So I do this in a really dumb way, but it turns out to take like no time. For every one of every sign, I calculate the distance from where the player currently is. Then I sort them. Then I pop the top 30 off, excluding ones that the user has found. So this is like n log n, but actually taking the 30 smallest items from a list of 500 is just log n, because you just allocate 30 buckets and you just throw the things in there as you go. It's maybe like n log 30 or something like that, like something very small. I don't know exactly, but nobody ever uses this algorithm for some reason, probably because sorting is so fast. So yeah, I literally sort the distance from you to every sign every single time this runs, which seems inefficient, but when you measure it, it's like 100,000th of a second to do it, so it doesn't really matter. Okay, so then it goes back to the client. So it goes back to the client gets, okay, so let's see what happens here. So how did we call this before? So we called start dynamic, and then, yeah, so we called start dynamic to tell the server, hey, you start your loop, that's just to monitor what the player's doing every 2.5 seconds. And that's it. And then the other thing we did here was we made it so that this dynamic running event, when the server sends a message to you on this event, handle new dynamic frames. And so whenever this gets called, it gets called with like a TT dynamic run from data. So let's look at game types. So this is what it is. So dynamic run from data is a kind, which is like a marker, from sign name, and a bunch of frames. A frame is basically saying, say you're running from sign A, and there's like 10 places you might run to from there. Each one of those things, each one of those signs will have its own frame. It'll have its target, sign, ID, and name. It'll have the places of that race, and it'll have your place of that race, if any. the places of that race are stuff like, oh, Jimbo got 3rd place. Here's his user ID and here's how long he took. So yeah, all it'll say is like from A to sign X, here are the top 5 people. By the way, you never did it. Or by the way, you're in 4th place or something like that. And then that gets assembled together. Okay, so we got these frames back. Set up dynamic visualization. So when you get a frame, there's some uniqueness here. Every run, you'll only get a frame one time. Like from A to, if you hit A sign to start, you'll exactly one time get B, or 0 times, but never twice. Let's say a bug. So what happens when you set up the dynamic visualization for a frame which you just got? Because when you get the when you get the data, you're not done yet. You got to keep updating the time display. Because like right now, on my run from A to B, I might be in 1st place if I were to finish now. But if I sit around a bit, I'll roll down to like 2nd or 3rd place. So get a create UI. So this enforces a uniquely named billboard GUI that will be attached to the sign. I did this in a very simple way now, just a billboard GUI with like a frame and a text label inside. Okay, so this only happens once per sign, so it's okay. So we get the sign, then we set up a render step. So every time the client renders a frame, we're gonna calculate the distance of the player to the sign. If it's greater than max, we just bail out. We don't do anything, and we turn off the billboard GUI. This is to stop load and to not overload the screen visually. And then if we made it and the thing is enabled, it's disabled, we gotta enable it again. Okay. Then we're gonna calculate the text. If there's no text coming back, meaning like something got screwed up or the race ended is typically what it means. Then we disconnect this thing from render step and we're done. We got the text, we've dumped the text into the text label and we're done. So how does calculate text work? And now you get to the real messy stuff. This is a pattern that is very hard because although it seems simple, relativistically describing your place in a race when you may have never run the race, maybe nobody ran the race before, maybe you ran it and you're ahead of where you were before in seconds. So like say you ran it and you got 3rd place with like 10 seconds before, and now you're on 9 seconds, but you're still in 3rd place because the 2nd place guy got 4 seconds. You're sort of fitting in there in the slot. Like you're simultaneously juggling place and time. So I'm not going to go into super details, but basically it's like if anybody ran this thing before, if I ran it before and got a proper time, we're going to display things one way or the other. Anyway, this gets very complicated, and actually just describing it to you, I realize there's a bug here. Because if I'm the only one to have run a race, this will hit, and this will hit, but it'll look like, it'll say like I'm in 2nd, when in fact I should be in 1st, because it's me. Or like you can never get 2nd if a race has only been run one time exactly by you. All right, so that's how the game works. When I hit play here, I'm running locally against a separate database. So when I hit play here, my character got created, the scripts got allocated, the server scripts are just sitting there. Let's just get this thing going. Takes a bit of time to start. So I'll hit this. Let's run over here and see what we got here. We got it. So that was interesting, right? As time was going down. Okay, so that was a bug because it said new 9th and it was actually 10th. So there's still a couple off by 1 bugs, and this is the thing that I need to really set up some kind of integration or unit testing for, because the actual like logical, there's multiple ways to solve this problem, and you get off by 1 errors if you focus too much on the one where you have done a race versus haven't done a race. Anyway, so that's just an intro to like how coding works in the game. Good luck with your own creations, everybody. Bye bye.